Hello, and welcome to today's episode of Rawkode Live. I'm your host, Rawkode. Today, we're going to be taking a look at Litmus, a chaos engineering project that aims to bring chaos engineering to Kubernetes in a cloud native and Kubernetes native fashion. Now, before we get started on taking a look at that project, I also just want to encourage you to please subscribe to the YouTube channel and click the bell, and also join our Discord community where we have lots of conversation during the show and after the show to discuss all the projects that we cover. Now, joining me today to discuss Litmus, members of the Chaos Native team, Uma and Karthik. Hi there, how are you both?
Doing great, David. Thanks for inviting us here. Happy to be here. Looking forward to this live session.
Yeah, I think chaos engineering is getting a lot more traction. I see a lot more people talking about it day after day, month after month, and I'm really excited to be able to uh, just get a taste for what Litmus can do to my Kubernetes cluster, both good and bad, and then also worried about what it's going to uncover in some of my actual production clusters. But I guess that's a problem that we all have to tackle eventually. Do you both want to just take a few moments to kind of introduce yourself, tell us a little bit about you, and then we'll start talking about Litmus?
Sure. Again, thank you and happy to be here. I'm Umasankar Mukkara, CEO of Chaos Native, and also I'm a maintainer on the Litmus Chaos project, which is now in CNCF sandbox. To tell a little bit more about me, I live in Bangalore with my two sons and my wife. I basically have been a technology architect in the past. And about 10 years ago, I jumped into entrepreneurship with starting CloudByte, a storage company, which then we pivoted into OpenEBS to write storage for Kubernetes, which is still one of the popular projects in CNCF. And then while I was doing OpenEBS project, we tried to do chaos engineering for OpenEBS. That's when Karthik and I started writing Litmus, which became a CNCF project. And then we recently spun off the project from my data into a company for its own development. The project's to focus on this project, and it's Chaos Native. We also helped launch a chaos conference called Chaos Carnival to focus more on cloud native chaos engineering and also a little bit more open and open for everyone kind of a thing. So that's a bit of my introduction. Looking forward to this session here.
Cool. Let me go ahead and introduce myself. Hello, everyone. I'm Karthik. I'm the lead maintainer of the Litmus Chaos project, also from Chaos Native. So I have a shared history with Uma. We worked on OpenEBS in my data, and we came up with Litmus as a way to test the resilience of OpenEBS, and over a period of time, felt it's useful for everyone else, and it grew as a separate project. Having a blast maintaining Litmus and interacting with the community. And I'm really looking forward to this session. Yeah, glad to be here.
Awesome. Thank you very much. So, I believe I've got some slides where we're going to just kind of cover what Litmus is and give everybody a little bit extra flavor. So, if we can get that screen shared, we'll jump through to the slides and then we'll move on to the hands on component afterwards. Awesome. Thank you very much.
All right. Thank you, David. So, with that introduction, I just want to take about 10 to 15 minutes. After that, I think David has plenty of a live session with Litmus. So, what I want to do here really is talk very briefly about chaos engineering that we all know of and the new cloud native chaos engineering, and then introduce the project, why we started Litmus, really. So quickly, chaos engineering is all about avoiding downtimes. Unplanned downtimes are always expensive, right? So you don't want to be that doing that. So what we have seen so far in the last decade is test, don't wait, right? So you do the testing on the operations side of your DevOps loop, and then find the issues or tunables that are needed and get back into the shape, right? So this is we know that. So far it's all about trying to do it on demand, or you do chaos engineering after you burn your hands with some expensive downtime. That's really been the case, and proactive chaos engineering is slowly catching up. The reason why so many things are happening around chaos engineering is there is a real push from the new ecosystem around cloud native. I'll get to that, but so far how it's been done is, it's done based on a need, and it is generally done by SREs on the operation side of it. You don't have a very tight integration of chaos engineering itself in CI and CD, and generally observability is not a pre-planned thought, rather it is an afterthought. And communicating with management, convincing the management is all based on the need, right? So chaos engineering is a great practice, that is a proven practice, but it is not like a science where everybody knows how to do it, or it's not as easy as I know Kubernetes, but I also know how to do chaos engineering on Kubernetes, right? So that's not how it's been till recently. But chaos engineering is starting to begin. We all know that Kubernetes itself is, has crossed the chasm. Everyone is in the middle of adopting it or already adopted it. But chaos engineering for Kubernetes is still early market, I would say. That really means that there are new tools being available. People are beginning to think that we need chaos engineering now that I adopted Kubernetes, right? So we are going to see a lot of innovation. People like us trying to put chaos engineering into mainstream for bringing resilience into Kubernetes, right? So now let me talk a little bit about cloud native chaos engineering. It's really about trying to do chaos engineering specifically for cloud native environments. I would call it as cloud native chaos engineering. So what's so different about it, right? So these are the five principles that we think should be different about chaos engineering, right? Kubernetes and the regular cloud native ecosystem would not be as popular as it is today if it is not for open source, right? So chaos engineering should also be built, maintained in open source, right? So that's one thing that we see. And also it should be community collaborated, like all the helm charts, chaos experiments, chaos workflows should be developed in collaboration with the community. Then it becomes much easier. They're going to be much resilient, the test itself, and there's less chance of false alarms and all. And then chaos engineering, you start and then you end up maintaining all your scripts. So there is going to be an operator of its own, versioning of the chaos experiments. So you need to have custom resources, open API around that. Then comes how do you scale it? How do you scale your chaos experiments for a system that's got hundreds and thousands of nodes, multiple clusters, cross cloud, all this stuff? We just need to be able to manage chaos engineering just the way how you've been managing your Kubernetes configuration itself. That is through GitOps, right? So GitOps should be applied for chaos engineering also. And the last one, but they're not the least, how do you actually know that a fault is happened because you introduced it or there was a natural fault? Obviously, when we introduce a fault or multiple faults, you're going to have some disruption and you want to understand what's going on there. Oh, okay, this is still all right because I introduced it. Now I exactly know where to look at. So that's called observability. Observability is a super key thing. We call it as open observability. You don't want to get logged in into some of the observability tools. You basically try to keep open standards around that. So this is what I call as a set of chaos engineering principles for cloud native environment. And we built Litmus project exactly around these principles, right? We started about around 30 months ago, starting to build the first Litmus project, or a little bit more than that. And we started in open source. We built a chaos hub, chaos operators, and now we built a cross cloud control plane for chaos engineering where you can run chaos engineering on Kubernetes, off Kubernetes in the same fashion. You can scale them up using GitOps, and you can do the observability. So we're almost there with 2.0 coming out, soon. We just announced the beta is coming on 15th of March. So I'm looking forward to having more feedback coming from the community. So the status of the project itself, it's pretty vibrant, I would say. Even though Chaos Native, or earlier known as the team, was under Maya Data, we are the prime sponsors or maintainers. There are a lot of contributions coming in from all over the places, right? You can see some of these guys. The number in the brackets are a combination of either PR submitted, review previews, and a number of issues created, and so on and so forth. But we are also happy to say that we are now closer to 50,000 installations of this, and we are pretty soon going to go into at least the application for incubation is already out there. Hopefully, in the next few months, we'll get to that state, and a lot of traction from various companies apart from Chaos Native. I would say more than 1,000 users in various forms are there, but these are some of the primary users that we've been seeing, either contributing or using in some form, right? And primarily, the use cases for Litmus is pretty straightforward. You can use them in CI pipelines when you're testing your code. You can do chaos testing, and you can also use Litmus as a trigger to your CD, that your code is good. Now it can be deployed in production, and later you can also kickstart chaos engineering once the deployment is done, right? And you can also use it along with GitOps. And in general, CI/CD is one of the main reasons. And then obviously, you use chaos engineering in production, start with staging, and then move on into production, etc., etc. Right. So at the outset, it's pretty simple. Litmus is one installation for the entire enterprise kind of a thing. You have an Helm chart, you get Litmus portal, you bring in the experiments from the Chaos Hub. You can also set up a private Chaos Hub to manage the experiments, maintain the experiments among your team members or set of teams. It's like how you manage any other infrastructure code or the code itself, right? So once you set up Litmus, you get a Litmus portal, and then you run chaos workflows on any Kubernetes cluster as a target. Or now it is also possible to set VMs or bare metal as a target also, right? And then you can put all this configuration into any other CD tool like Argo CD, Flux CD, or Spinnaker or Jenkins X, and then move forward with that. So, in a nutshell, Litmus is one distributed chaos engineering tool where you can manage all your chaos engineering needs for all of your team members, and then run your chaos workflows or experiments at various targets, and then have all the results pushed back into Prometheus, and you have a single pane of observability for knowing what's going on, right? So one of the innovations that we did to achieve the scale and flexibility is to integrate with Argo workflow, right? So Litmus now at the lower levels it has its own operator chaos experiments, but at the upper level it is integrated into Argo workflow. It is not an Argo workflow by itself, but Argo workflow plus some intelligence to consolidate the status of the experiments and results. And then this is how we actually do GitOps and chaos engineering together, right? So this is a little bit of a details. You will write a chaos workflow, and then you write within that you will have a chaos engine. The moment you write a chaos engine, the operator picks it up, runs the experiments, and then we push the result and metrics back into Prometheus metrics or any other observability tool that we support. And we keep these experiments either in a hub, public hub, or you can also pull them into a private hub. It's nothing but a private Git repository where you manage your experiments, and the workflows can use a mix of experiments from both the hubs. or many other hubs as well, right? So we do have a lot of experiments that are required. I think we have about 40 plus experiments today, which are generally sufficient enough to do the basic chaos engineering, advanced chaos engineering if needed. And obviously, this is an open source project that is going to grow more and more. So there's always some new experiment that's coming. So we do have some fantastic experiments, new experiments that are going to come out in the next 3 to 6 months. We also do have a built-in observability analytics within Litmus. And also you can use the chaos annotations and metrics to put chaos indicators in your regular Grafana charts as well. So observability is an important piece for us, and we continue to improve that part of the area. And when it comes to the integrations, we are doing more and more with the help from community. Currently, we have integrations into GitLab, GitHub Actions, Spinnaker. And recently, we did fantastic integrations into another CNCF project called Captain. So basically, what happens is you can introduce chaos stages into those respective tools, which uses a CI library from Litmus, which underneath will invoke the regular Litmus experiments. So it's pretty easy to integrate. And we are also having architecture to introduce chaos onto non-Kubernetes targets. In this case, the experiments itself will run on Kubernetes as an agent, and then using the remote network APIs of the respective target, will be introducing chaos. So it's a little bit early right now, but we do have experiments for a few experiments for Amazon and Google, but a lot more are coming. And we see this area is a great area for collaborating with the community at large. So we're also having a lot of plans to integrate with CNCF projects, Flux, Crossplane, OPA. People keep coming. Okay, we are using OPA for security and policy control reasons. Chaos engineering also should be integrated into it. Why not? I think there is some work that's coming up. So before I leave it back to demo, Chaos Native, it's about we continue to provide free support, add code to the project, but we are also starting to. The purpose of Chaos Native also is to increase the adoption of Litmus in the enterprises where they expect the enterprise support and managed services. So we have started these services in some form already to a few users. Looking forward to hearing more on this from the users and the community and enterprises themselves. With that, I would like to say thank you very much for giving this opportunity. We'll turn it back on to the live session now. David, back to you.
All right. Thank you very much. I guess maybe we could just take before we jump straight into the hands-on section, why don't we kind of tackle a few questions there? Like, I think you made it very clear that, in order to do, any sort of chaos within a cluster, is that monitoring and observability are almost paramount. Um, what would happen, if I don't have very good monitoring and observability and I let Litmus loose in my cluster? I mean, is that just going to all go bad?
Basically, chaos itself is you're disrupting something that's working, right? So the idea is you disrupt something which you expect might happen, and then you see whether my services are up or live, right? So what happens to your cluster really depends on what is the chaos that you are introducing. And you could use a node kill experiment and then kill all the nodes. Then you can bring it down, right? It's very much possible. But the idea of observability is somebody knows that they are doing it, right? They're doing chaos. So the blast radius could be huge or could be low, but sometimes you have to have an eye on what's happening with chaos as a perspective in it, right? For example, I have my Grafana chart or any other chart showing the CPU usage of all my services on my cluster. And now, for a certain amount of time, a couple of hours ago, there was disruptions everywhere. And was it the time that chaos was introduced? And what was the chaos that was introduced? In which namespace it was introduced? That perspective, when you have it within your observability tool, it makes 100 times easier for whoever it is looking at to debug. Otherwise, you're just throwing more disturbance into the system, and you know that something is wrong. You're debugging. The purpose of chaos engineering itself is to find what's wrong with my service. You debug and you fix it. So observability is pretty important in that. At least marking that this is the chaos that I introduced during this period, having that available for the users is very important.
Yeah, definitely. I think that makes a lot of sense. I think I like to think of this as like we write code based on assumptions that we think this is what the code is doing, and then we correct that or we test that with tests. And I feel like this is a good application of that to our production infrastructure, or I guess any of our environments, in that we run these applications that are horizontally scalable and fault tolerant. At least that's what it says on the box. But how often do we actually ever test that? How do we know that if I lose a node or if I lose a Kafka consumer, that is going to be moved over to another machine or picked up by another horizontally scalable pod? And Litmus is the way for us to take those assumptions and actually make them assertions, and actually confirm that the behavior works the way that we want. And I think that is really powerful. Um, is this something based on the experience of you using this yourself in OpenEBS and the customers that you've spoken to, do people run this in production or do they run it in pre-production environments?
Our experience, nobody starts not just Litmus or any other chaos engineering directly in production. One of the challenges always for the SREs that we keep hearing is, I finally determined that chaos engineering is going to help me make my systems better, but my management is not yet approved, right? So how they do typically is they don't even go into pre-production. They go into a little bit of a staged environment, and always, nowadays the upgrade environments are pretty robust, and people invest in a chain of the stages. You go with the development, and then staging, pre-production, and then production. These are at least the four stages that we know of, and some people may have even more stages than that, right? So it is okay to start with the development itself, right? So chaos engineering should be thought of as a next step to the development, if possible, right? So that's how at least our project makes it totally declarative, where however you write code to deploy a Kubernetes resource, you write one more declarative interface to do some testing around it, right? So it's very easy, and it comes as an extension to your development process. So you can start with that, and then into CI pipelines, right? You introduce a chaos stage, and then you start with very small tests. You have nothing to lose if your CI pipeline breaks totally. In fact, it's a good thing that you're breaking right now. And then go into the staging and then run it for a few months. You see value in it. You get a chance to convince both your developers, your own teammates, and your management, and then run a game day on your staging, and then go into production, right? So that's typically how it's done. And we have seen significant results being produced in that fashion.
All right, thank you very much. We have a couple of questions from the audience, so let me pop the first one up there. Moz, welcome back. Nice to see you again. Has asked, how big are the hardware or networking resources that Litmus requires to be running inside of our cluster?
Right. The new Litmus, we are talking about 2.0, right? The Litmus so far 1.x till a couple of months ago is you need to install Litmus on every Kubernetes cluster wherever you're going to run, right? Now, we are trying to make Litmus into more of an infrastructure tool set for your entire Kubernetes ecosystem, not just one cluster, but for a set of team members, right? So for that, you need to install Litmus application, and to begin with, it is the amount of resources or half a meg of memory and half a CPU is good enough. But it is a Kubernetes application. It is highly scalable, and the more experiments that you run, it just can take up more resources as you need. But we try to keep it as thin as possible, and it's about half meg of RAM and half a CPU should be good enough. Karthik, you want to add something more to that, please? Go ahead.
Yeah, I think you've answered it, Umar. Having said that, the chaos control plane and the chaos pods that are launched to run the experiments can have the resources defined for them in a declarative way. So we'll talk about that when we see the chaos engine custom resource. So you can define the requirements and the limits that you want there. In case you are running a lot of experiments in parallel, etc., you could control that. The minimum requirements, as Uma said, are low, but they may add up to more when you're running a lot of experiments in parallel, but you can control them.
Yeah, so it's pretty lightweight, but if you want to cause absolute carnage in your cluster, of course the resource consumption is going to grow with the number of experiments that you want to deploy. So I think that makes a lot of sense. And I guess the answer was there is, whatever you want to throw at it. Okay, we got another question from Vishal. Does Litmus allow us to schedule chaos? I mean, like if I want to, I'm assuming, and I'll throw some extra words in there, is that if I want to say next week at 3 a.m., I want to run some sort of availability zone failure scenario, is that something that is possible with Litmus?
Yep. Yeah, scheduling is one of the core features of the project. We allow it in various forms, and you can run it instantly. You can schedule it, and you can rerun a previous one. Many forms of it, right? Every hour, every day, every week, and you can do multiple combinations of that.
Nice. Well, I think that's plenty of chit chat. As hopefully people interest is peaked. I think we said a lot of really interesting stuff. I really want to see this in action. So I believe Karthik, you are going to walk us through and guide us through the installation, and then some more advanced demos as well on top of that. So I'm very excited, and I will hand over to you. You're on mute, I'm afraid.
Sorry about that. Let me share my screen.
Awesome, thank you.
I hope my screen is visible.
It is. You are live. Please take it away.
All right. So this is the agenda we have for today. We'll do a quick run through of the Litmus installation. What you'll see on the documentation today involves installation of the Litmus operator, pulling the experiments from the chaos hub, and then running the actual chaos. What we'll do today is install the Litmus version that is upcoming. We have it already in beta. So we have a component called the portal, which is essentially a web UI which will help you orchestrate chaos. So we'll do a quick installation of Litmus. After that, we have a real world chaos scenario. We've taken Kafka workload, a stateful set Kafka cluster, upon which we will run some test load and kill one of the brokers. And we'll see what happens. And we'll see how you can hypothesize about the behavior of Kafka when you inject this chaos, and how you can place that hypothesis in a declarative way in like a Kubernetes custom resource called the Litmus Chaos engine. And after that, if we have some time, we'll do chaos on AWS cloud. We'll do a kill of an EC2 instance and verify the health of the application that is going to be impacted by it. So this is what we have for the agenda and demo objectives. I'll very quickly go ahead and show you the procedure to install Litmus. So we have the Litmus Chaos /Litmus. This is the repository, and I am inside a folder called as Litmus portal. You could install it via a Kubernetes manifest like this, a standard YAML file, or you can also do it via Helm chart. We have a Helm repository at Litmus Chaos /Litmus Helm. So you can pick your bundles from there. For now, I'm just going to use my manifest. I've got two clusters with me, cluster 1 and cluster 2, both are on GKE. I'm going to install the Litmus portal on cluster 2. And while that is going to come up, we'll move to do the app chaos demo on cluster 1, in which I have already installed the Litmus components. And before we get on to doing the app chaos, I'll also show you another slide which talks about the demo setup and the use case and the hypothesis, all that. For now, let's just install Litmus. So I have a VM instance here, which I can use to install resources on my Kubernetes cluster. So it creates Litmus namespace. As you can see, I have executed a command before where there is no Litmus namespace. We create a Litmus namespace. We create some dependencies like the config maps and persistent volumes. And then we actually deploy the Litmus microservices. So Litmus has a control plane that consists of a GraphQL server. It has a MongoDB to store the state of chaos. And it also has a few other RBAC related resources that get installed when you do the installation. Oops. All right. Now you can see I have the three paths running. There's a front end, which is actually the UI with this GraphQL server, and then this MongoDB. I'm going to try and access this, right, and bring up the UI on my browser. As we do this, if there are any questions, David, please feel free to interrupt me. I can take those questions as we go along. So I'm using Node port, as you can see by default here. Let me find out the external IPs of one of my nodes, and I'll use that to bring up the portal. So this is the IP, and I've got 32527. I've already exposed these ports on my firewall. I hope that's right. Okay. Yeah, you can see the portal is now opening up. By default, it takes admin and admin as the username and password. I think so. Okay, I was wrong. It is admin and Litmus. So once I get into the portal, I have the option to set up my project. So the Litmus portal allows you to create your own project. Each user is allowed to create his own project, his or her own project, into which they can invite other team members, and they can invite team members in different roles as view admins or as people who have edit access and can run chaos. You could do different things. I'm just going to create a project called Rawkode. I'm just going to fill in some details here. Just going to provide some information. All right, so it has updated the details. I'll just navigate on this browser and just show you the different options that you have for a few minutes before we go ahead and do some experiments. Like Uma was mentioning, in case of Litmus, the unit of execution of chaos is workflows. So your workflow could be just one chaos injection, or it could be a set of chaos injections ordered in a particular manner, in sequence or in parallel. You could also use workflows to run some kind of a benchmark load or some other test workloads along with chaos just to see how it behaves under stress. So workflows are pretty flexible. You can construct them using the browser, the portal browser, or you can actually create them on Git, source them into your portal instance and execute it as well. So you can create predefined workflows. We also ship what's called as the My Hub, that is a chaos hub inside the Litmus portal. The chaos hub that you see here is the same as the one you notice in public here at hub.litmuschaos.io. So this is some kind of an open marketplace you can think for chaos. So this is where our community is focused on contributing experiments into and picking experiments from. There are some categories of experiments here. The most used ones or the most used experiments are from the generic category. Most of the standard Kubernetes fault injections are available here. But there are also experiments of other categories. For example, we have OpenEBS and some Kafka and some Cassandra experiments. These are essentially the same faults as you would see in the generic experiments, along with some native checks that are very specific to these applications. And they can also consist of experiments that are related on specifically to that app, and they're not general Kubernetes pod failures or those kind of things. So you have an instance of the hub embedded in your Litmus portal. So you can construct workflows by picking experiments off the hub, but it's also possible for you to connect your own chaos hub. Let's say you have your own downstream implementation of Litmus experiments, and you have that in a private hub. You can actually pull that via some access tokens and use that for creating workflows. As of now, I have a workflow which is already constructed, so I'm going to use that. Let me move to the target section. So the target is how we call chaos execution environment. So in this case, the same cluster that has this particular portal installed is also the target, which is also called self-cluster in Litmus terminology, and it shows that it is active. But I could also connect other Kubernetes clusters here. I can connect a target, and Litmus portal will actually communicate with that cluster and inject chaos there via some agents. So I have this local cluster self-registered, that is, the portal is installed on this cluster, and it is also an object of chaos. And once that happens, you will actually see a few more pods being spun up here. So you can see something called as a subscriber, which is essentially the agent, which is actually going to relay instructions from your portal onto your cluster target. And there are some workflow controllers, the chaos operator, and a few other microservices, which we can talk about later, which help you to do chaos in a better manner. So with this, I can go ahead and quickly jump to the demo environment that I actually wanted to show you and do chaos on. So we are done with the installations part of Litmus. The portal has been installed. It's as simple as this. And I can go ahead and run new experiments by creating a new workflow. I can schedule a workflow, and I can select the target on which I want to do chaos. There are some predefined workflows just for illustrative purposes that we've created. You can feel free to use them, or you could create your own workflow. And when you create your own workflow, you have a few options. You can select them from the Chaos Hub. Like I said, you can select the experiment here, and you could choose to go ahead and add tunables for a particular experiment. This will eventually give you a Chaos Engine manifest, which looks something like this. I can show you that once I've finished adding all experiments. So this will actually open up a browser which is going to show you the manifest that is actually going to be created on your target cluster when you run chaos. This looks very similar to an Argo workflow like I mentioned, but it has a few other characteristics. The steps are executed by a specific image which understands Litmus API. And this is called the chaos engine, which is essentially how you define your chaos experiment to be like. And this is a very quick snapshot. It has some references about what application you want to do chaos on, and what experiment you actually want to perform, and what are some of the tunables or options you want to run the experiment with. That's what the engine exemplifies. It is essentially a definition of how you want to do your chaos, what chaos you want to do, how you want to do it, on what application you want to do, what are the run properties you would associate with the chaos experiment. All that can be defined here. And the workflow embeds this chaos engine along with a few other steps that are setting up dependencies. And then you go ahead and run this. I don't have an application right now in this cluster to do my chaos on. So I'll just stop at this point and I'll probably go ahead and show you the demo environment where we'll do the actual chaos today. Before we go there, I just wanted to know if there are any questions around the installation process.
Yes, I think the installation looked really simple, which is great. There were a couple of things that popped into my head as you were working through that.
Yeah.
Like it's actually using Argo under the hood to do this, right? So it's kind of working hand in hand with that project, which I thought was
That's true.
yeah, really nice. Rather than reinventing the wheel and doing something completely bespoke. So I like that. We also had a
Yeah.
question from Moz who asked, is it possible to target a specific workload and deployment? And I think you just kind of showed that if you can pull that YAML back up.
Yeah, I think that's a great question. Thanks for asking that, Moz. Yeah, Litmus, one of the crucial differentiators of Litmus is the fact that we can isolate the chaos targets to the workload. For example, if you have a deployment that you want to do chaos on, and you don't want chaos to be, you want to just restrict the blast radius to that deployment alone, and or maybe any other downstream application that's depending on that deployment, but not any other application. You could choose to do that in the way you construct your chaos engine. There are some annotation checks that you can do, you can turn on in Litmus, and it's going to look for a chaos annotation on a particular workload, and it's going to filter only those applications that has those annotations, and it also has the label selectors that you mentioned, and it's going to kill only that. I will show that chaos engine in slightly more detail when we do the Kafka demonstration. But I'd also like to just augment what David said about the workflows. I think you made a great point about not reinventing the wheel, David. So when we started off Litmus, and this is how you'll find it in the current documentation as well, the custom resources that were brought up for Litmus were capable of doing experiments in a particular way, individual experiments. But we thought there's a lot of value in allowing users to run complex scenarios because, misfortune doesn't come singly. Sometimes it comes in clusters. So you have more than one failure occurring at a given point of time. All the same, a lot of people want to do failure testing when they're running performance workloads. When they're doing performance testing, they also want to do some chaos and see how things are behaving. We found Argo as workflows as a way to enable that. And in fact, the idea was brought on board by one of our maintainers from Intuit, Sumit, who was using Litmus that way and then suggested, why don't you actually make it the unit of execution within Litmus? So I think that's the backstory behind using Argo.
Okay. I'm curious as well. You showed the Chaos Hub. I mean, are there any plans to use the Artifact Hub as a way to store these Chaos experiments?
That's a great question. We have had this, we have touched upon this in the past, specifically when we contributed Litmus to CNCF as a sandbox project. Right now, the hub lives as its individual entity, and the artifact hub has the artifacts for deploying Litmus, both the Litmus control plane, and you can also have the Litmus experiments being installed via a manifest that you pull from the artifact hub. So the Litmus experiments that you see here, you can actually install them via manifest, and the hub provides you more context and metadata about a given experiment, what it's going to do and why it's useful, and what are the artifacts associated with that. There's an experiment CR, then there's a recommended service account that you run your experiment with. So in Litmus, each experiment is associated with the service account which you could choose to use, because we felt that in a multi-tenant environment, when people are running in a self-service model, each running their own experiments, you don't really want them to run experiments with all the permissions that they can get. So we just defined a minimum set of permissions for each experiment, and we are recommending users to use that, but it's not necessary. If you have autonomy over the cluster, you can have an all-encompassing service account that does all the experiment. but we have all that information around what this experiment does and what are the associated manifests, all that in the hub. Whereas in the artifact hub, you will find the same experiments available for installation as a Helm chart. So we have a space for both to coexist, but it is a possibility. We really don't know what holds for the future. As the project grows within CNCF, we might probably revisit this this topic and this discussion to see how this hub can go on, whether it can run individually or whether it goes and gets merged into Artifact Hub. For now, I think Artifact Hub and the Chaos Hub both provide you options to pick experiments from.
Okay, I'm going to ask you a very difficult question now, but I think the most important one of the day. And does the mascot have a name?
We call it the Chaos Bird. There's a very interesting blog. I can probably share that on the live stream comments later as to how this came about. We wanted to make it a very restless sort of little thing which always does experiments. So you can see it wearing some kind of a coat, always going about a lab, trying to do some experiments. So that was the general idea, and you'll find a lot of the mascot in the Litmus website as well in different poses. So yeah, I think it's something we got positive feedback on. People liked the Chaos Bird. So yeah.
Yeah, definitely 10 out of 10. In fact, I've got to say, the design and aesthetic of the dashboards as well, and the logo, it's all just really polished and cool. And I definitely need to get some Chaos Bird stickers now. It's definitely one of my favorite cloud native mascots. So, anyways, that's a small segue, but I just had to say that was awesome. I really like it. So, I know we're about to do a more advanced demo, and maybe you'll tackle this here, but there's something that's kind of popped into my mind. I can imagine me running this in. I'm a little bit crazy at times, and I will run this in production. I know I will, because I want to really test this in a real world situation. If things are going badly with an experiment, is there a way to revert, undo, delete, stop? Am I committed to the chaos, or can I pull out of the chaos?
You could. So the Litmus supports an ability to abort experiments. So each chaos resource in Litmus has an engine state, which is essentially reflective of the current state of your experiment. It is always set to active by default. You can go patch it to stop, something that is going to be made available in the portal. You could disable portals for the portal today. You could disable the workflow in the portal today. That's essentially going to stop it from getting picked and stop the chaos from getting rescheduled. But we also have the abort feature coming up on the portal. It's already supported by the backend if you're doing things by hand. You just need to patch your chaos resource with a particular state, and it's going to revert all the existing chaos processes that have been started. Let's say I'm doing some kind of a network chaos where I've gone and injected some rules, network rules on the network namespace of the remote container targets. By aborting the experiment, those processes are going to be rolled back, and all the chaos pods that were brought up to do the experiment, to validate the hypothesis, etc., they are going to be removed as well. And there is something called as a chaos result. That's another custom resource. It is an artifact that's generated at runtime, which is going to have information of what happened thus far in your experiment and the current state that it was aborted. So you know for future that, okay, this was a run that was stopped. I can either restart it, or I can clear everything and start fresh again with a new hypothesis. So that's an option you could do. And it is something that we got a lot of feedback on early when we started the project about a couple of years back. So we said, if we want to use Litmus in production, we really want it to be able to roll back the chaos and stop things immediately. And yes, we recently were able to demonstrate that you could do this at scale as well. Let's say you're doing chaos on hundreds of replicas at a given point of time. So you need to be able to stop chaos on all of them. So that's something that we already support on a per experiment basis. The portal is going to enable that to be done for a workflow basis. I think that should be available very soon.
Nice. Okay, let's tackle one more question, and then I'll let you get back to your demo. Moz has asked a great question here. What he's asking is, can I configure the signal sent to my application so that I can handle maybe a graceful termination rather than a sigkill, which would be more of an abrupt termination of my application?
Sure. There are a couple of experiments that you would see on the Chaos Hub. I hope the Chaos Hub is visible.
It is. Yeah.
So you could see there is a pod delete experiment, something we also opened up a little earlier, and it has a few options for you to define the nature of the kill. For example, nature of the delete. You could do it with force. You could do it without force flags. If you do it with force flags, you're going to have a zero termination grace period seconds, and it's going to immediately remove your pod. That's about the pod delete, an API-driven pod delete. There's also another experiment, an interesting one called container kill experiment, which is a lot to do with signals, the nature of the signals that you can push to your application. So by default, Kubernetes sends the SIG term, and if you do have hooks that you already have, some kind of pre-stop hooks, then you will allow those to gracefully complete before actually going and killing it off at the end of the period, termination grace period seconds that you might have defined for your application. But container kill experiment allows you to specify the nature of the termination that you pass to your app containers. You can send SIG terms, SIG kills, all those kind of things. It's something that is, this is an experiment that is more of a remnant of a previous era before Kubernetes, where Docker and Docker Swarm used to rule the roost, and you could do a Docker kill, right? But it's something that you don't see too much in the Kubernetes world today. You generally go with SIG term, and then you can provide some grace period seconds for your application, and you can factor in how long you want to wait for your application to recover before you validate your hypothesis or come to the final conclusion around what happened to your app. By that, let me elaborate. Litmus allows you to provide something called as status check timeouts. I'm just opening up the API specification for Litmus, or rather what all you can provide in the Litmus Chaos Engine resource, the Chaos custom resource. There is something called as the status check timeout. Is essentially how long do you want for your application, wait for your application to recover before you actually call out the experiment as a failure or as a success. So these are things that you can tune when you're actually running your experiment, depending upon your use case. What is the nature of your application? What are its dependencies? For example, sometimes you use stateful applications which need to mount PVs. So you might delete them on one node. It has to get rescheduled on another node, but it has to mount the PV before it actually comes up. How much time does that typically take? Depends upon your stateful storage solution provider. There are so many variables depending upon your app type and your experiment use case itself. So you could choose a lot of things, a lot of hooks in Litmus to help you arrive at the correct result, so to say. As far as the injection is concerned, with the pod delete experiment, you could do force and you could do force deletes and the graceful deletes. We also have the container kill experiment where you can send a desired signal to see how your app or app stack is behaving.
Perfect. Thank you. All right, I'll let you get back to your demo now.
Sure. So this is the demo setup that I have. I just wanted to explain it for a second before delving into the demo itself. So I have a cluster in which the portal has already been installed, and it comes with all the Litmus microservices. You have the Litmus agents, the workflow controller, the chaos operator. I have a metrics exporter and the actual chaos experiment CR artifacts. There's also a monitoring namespace. So I'm monitoring my Kafka cluster here. And this is also where we'll observe the Litmus metrics and do what we call as chaos interleaved Grafana dashboards. That is, it's essentially a Kafka dashboard that's also annotated with chaos metrics. So you know what's happening to your app when chaos is going on. And coming to the main workload itself, it's a Kafka cluster. I have 3 brokers. This image actually shows 5. I actually have 3, along with Zookeeper to maintain state. And as part of this experiment, we are going to create some test load. I'm going to set up a very simple Kafka producer consumer pair running as 2 different containers in a single pod. And we are going to create a message stream that has one topic with just a single partition, but we are going to replicate that partition across 3 brokers. So you might all know that there's going to be a partition leader amongst those 3 brokers, which is actually going to handle the data traffic, the writes. So we are going to identify the partition leader amongst those 3 brokers, and we're going to kill them. Once we kill that, there's going to be a failover. There's going to be a partition leadership failover. So there's going to be another broker which is going to take up the leadership of that partition. And the broker that we kill might happen to be just a partition leader, or it can also be the active controller or the controller broker, which is actually keeping this Kafka cluster together, orchestrating failover, speaking to Zookeeper and all that. So depending upon which of those you kill, you will probably see a slight difference in the experiment execution. And what happens when we kill is, of course, the failover happens, but the consumer that we've created here as part of the test load setup is configured with a message timeout. So it has a timeout on how much time it can wait for before it stops receiving IO or data. And if there's no data received within the timeout, it's going to give up and the pod is actually going to fail. And if at all the failover happened quickly enough and your timeout was set correctly for this environment, and it depends a lot on the environment you're running this in, depends upon the storage classes you're using, the network, the CNI provider, or so many things like that. So we are going to hypothesize about what's the right timeout. We're going to start off with something that's small. We're going to see how the experiment fails and what are the information we collect as part of the failure. And then we are going to do the same experiment with a larger timeout and verify our hypothesis of an unbroken message stream, right? And the experiment should just continue. The message stream should continue. It should not be broken, all that. But as we do this experiment, this is essentially the use case that I'm going to demonstrate. But many times when you do your experiments, it's not just your core application behavior that you're going to check. You may have that as one of your main constraints, but you also have a few other things you want to observe as part of your experiment. So this is where observability is very important. You want to know what's happening to different services when you do your experiment, and you should be able to visualize that. And that's why without observability, chaos is like shooting, trying to shoot a dark cat in a dark room kind of a thing. So you need observability. What Litmus also provides is the ability to consume observability information from the outside. That is, you could Litmus has the ability to look for Prometheus metrics or the like. For example, you could basically say during this experiment, when I start this experiment and when I end this experiment, I expect that there are no offline partitions or under-replicated partitions. During the experiment, when I kill the pod, the broker, it's possible that I may have under-replicated partitions because one of them is down. But when I begin and when I end, eventually, I want things to be fine. I should not have any problems. And I should never experience data loss, or the data integrity should be maintained. I should not have offline partitions. All those things are auxiliary checks you want to make, while the primary constraint is I want to see my message stream to be unbroken. So these are things you want to factor into your experiment, something that we call as declarative hypothesis. Many times you run your experiment as automated runs. So you might not be at hand always to see what's happened. So you want some things to be automated, some checks to be automated as well. So we'll do that in Litmus. I will show you how to do that in the experiment. And all these steps that I mentioned, all about the experiment, the prerequisites to set up the cluster, what the use case is about, what's our hypothesis, and what are the demo steps, all that has been documented in a README here. We recently ran this as one of the bootcamp sessions during Chaos Carnival. So we have all that information here. So please feel free to take a look at this after we are done. Okay, so without much more discussion, let me just go ahead and let me go ahead. I have lost my cluster instance here, but don't really mind because I have my lens set up for the same cluster. So you can see I have Kafka clusters. There's 3 brokers. I have the Kafka exporter already set up along with Zookeeper. And then I also have the Litmus microservices that I mentioned are running. And I have a portal here in which I have already run several workflows before this. I'm just going to make use of the same setup. So let me schedule this experiment to run. I'm going to select the self cluster. That is, we're going to do this experiment on the same cluster where the portal has been installed. I already have my workflow manifest in my workspace, and I'm going to say that I'm going to create my own workflow, and I'm going to upload my YAML. So there is a workflow manifest called Kafka WF multiprobe. I've selected that. So here is where you see the big manifest, right? I'll take a few seconds to describe this. There was a good question sometime back around, can I isolate my experiment to a particular workload? So this is the section where you do it. You provide the namespace of the workflow of the workload, some filter such as the label, and what is the app kind. Then there's something interesting. It's called as the annotation check. I've set it to false here, but you can actually turn it on. So what this does is, let's say there were multiple deployments or multiple stateful sets rather, which share the same details such as our app Kafka. Maybe one of them was running with dev image, one was running with a production image, or it's running with a different fix, different instrumentation. You want to target a specific workload. So I can choose to do a second level filtering by adding an annotation on the stateful set called litmuschaos.io/chaos set to true. And I can set this to true. So it's actually going to find out all these stateful sets that match this criteria, but it's also going to check which of them has the annotation. And then it's only going to target that particular app. And I'm using the service account called Litmus admin to run this experiment. And the chaos engine, which is what I'm talking about, also has a way for you to specify whether you want monitoring turned on or turned off. So I have a Kafka cluster dashboard here on my Grafana. I have used the standard JMX exporter dashboard, and we've just instrumented it with Litmus annotations. So whenever chaos happens, you will see those annotations appearing here. And if I want this monitoring to be enabled on a per experiment basis, I can choose to set the monitoring to true, or I can turn it off. And you can see this is the hypothesis I mentioned. So right at the beginning and at the end of the experiment, we don't want any under-replicated partitions. So I am querying a Prometheus server, which is at this endpoint. And this is the query that I'm going to run. And I'm going to do some comparison. I'm going to check the deviation, or I'm going to look for the desired status here. Edge mode for a probe, and we call these probes. All the declarative hypothesis hooks are called probes. The probes can run in different modes. Edge indicates that it is going to run in the beginning and the end of the experiment. And we have another probe. It's the same Prometheus probe. I have a different metric here, not just at the beginning and at the end, but through the experiment duration. I don't want any offline partitions. And this is going to be continuous mode. So even as the chaos occurs, we are going to validate this. There are some run properties, as you can see, as you could imagine. These are the polling intervals for this probe to get executed, and characteristics for retrying that if there is a failure. There's also an other probe, which is called as a command probe, where you can see I'm running a kubectl command, which is something that is telling you that a pod which has this label, Kafka liveness, which is essentially the load pod which is being brought up, should have the consumer container always ready through the experiment duration, during the chaos period. And that's the indication that the message stream is unbroken for me. So I have all these probes set up. Then I have some information about the Kafka deployment itself. What's the service name? What's the Zookeeper details? how do I want to kill, all that information is provided here in the chaos engine. So this is the chaos engine. Once I'm happy with what I have, I'll go to the next step. So in Litmus, we define or we enable what's called as resiliency grading. So this workflow just has one experiment, but I could choose to have more than one experiment, in which case I can assign some criticality to those experiments. For example, I'm doing a pod failure with 10 points, but I might just be doing a network loss with 7 points. Depends upon how much the experiment means to you, which is also reflective of how much your application is or your infra is already mature to take those experiments. So I could choose the weights for the individual experiments, and eventually this will help me get a resilience score for this workflow, which is essentially a ratio of weight into the experiment success points divided by the total points, right? And that is something you can compare release on release, build on build, to see what's happening with your application and how much you are becoming more resilient. I just have one experiment, so I'm going to select all points. I have an option to schedule the experiment once or repeat it multiple times according to a schedule. I'm going to just do it once. And yeah, that's it. And if I did not show it to you clearly, this experiment is now being run with, I think, something like 75 seconds, if I'm not wrong. Yeah, so this is something that works on this cluster. I can repeat this experiment. I actually wanted to do this experiment with a lesser timeout, but I just got started. This timeout is actually good enough in this case on this Google cluster that I'm running. So the experiment is expected to pass, and we'll see how that success is reflected in the different resources, chaos resources. But if you lower that time, it's actually going to fail. So I think let's take a look at the success case first today. Once your workflow is running, you can see the visualization, the progress. So you just pull the chaos experiment here, and then it started doing the chaos. If you go to this lens setup, you can see some pods being brought up. So the Kafka broker pod failure that you see here is actually the experiment pod that has been brought up to run the chaos business logic, right? And it actually started a liveness pod here, which is the test low. And I can basically show you what that is going to throw out. There are 3 containers. I'm just going to show the Kafka consumer. It's basically a very, very simple message stream. You can see that it is just going to print a string and timestamp. It identified the leader broker, the partition leader, to be Kafka 1. So you can actually see that this is going down. And it has a readiness probe. So it's actually going to take some time before it actually comes up. Right. In that period, we don't want this container to give up. We don't want the consumer to give up and throw an exception saying the timeout has been exceeded. It has to pause and then continue. That's our hypothesis. And along the way, verify a host of other things, offline partitions, unduplicated partitions, and all that. You can see 75 seconds was good enough. So it's a pretty slow setup. That's why I had to give a bigger timeout. The message stream is actually continuing. As you can see, it's not broken. So that's good news, because you got your timeout right in your first shot. The hypothesis was validated, but often it doesn't happen like this. You have to play around a little bit in order to actually come to the right conclusion. So I'm talking in the perspective of you running chaos experiments to identify what is a good deployment attribute. But if you just flip this logic, you could run this on production, and you could just find out if your things are all working good, what worked earlier, does it continue to work today, all of that stuff. So you can see the Kafka pods here. The pod is going to come up. It has been restored to its original state. And while all this is happening, if you take a look at the Kafka Grafana dashboard, you can see this red area here, which is actually indicating the period of chaos. So while chaos is happening, you just have 2 brokers, you don't have 3. So you have some underreplicated partitions, which will and did eventually recover when you have all the brokers. And you could see the broker count resumed. The broker that was killed probably happened to be the active controller, so you did not get a broker count value here, but it's resumed after that. You can also get these annotations on all your panels if you do it as a Grafana annotation. So you can identify what happened during your chaos, what metric dipped, what increased, all that information you can find it, right? And we have run this a few times over the last few hours, so you can actually see that run across multiple times. So if you have not been on your system, or if you've been away and want to find out what happened when you were away and when chaos was executed, what were the metrics, you can use this. This is what we call as interleaved dashboards, chaos interleaved app dashboards. And the metrics are something that you can find. There are a host of other metrics. I just use the Litmus Chaos experiments to obtain these annotations, but there are also other experiments that you could make use of to construct dashboards of your choice. And with that, let's take a quick look at what happened to the experiment pod. So the experiment pod is here. It's actually completed. And I used a job cleanup policy of retain. So I can choose the choose for Litmus pods to be removed at the end of chaos, or I can choose for them to remain in completed state for me to go and check what has happened. So these are the pods, and if you just scroll up, you will actually see that it looked for some default checks whether the application is alive before starting the chaos. And after doing the chaos, or during chaos, it checked several of these metrics that we wanted it to, with what were defined in the probes. And the replicated partitions failed in the first check, but we provided some retries and timeouts. So eventually, it succeeded. If you want it a more stringent kind of a check, you can reduce the timeouts and retries. And there were no offline partitions. It was always available. And finally, the message stream continuity check probe did succeed eventually. So there was the consumer pod, which it always found to be running. So this is something that determines the hypothesis. So you can run your experiment, see what has happened during the course of your experiment using the Litmus portal. So the Litmus portal is a cool way to see what's happening. Experiment still shows as running because it is doing a few post-chaos checks, post-processing operations, and filling in details into your logs, which you will eventually be able to notice. So once this ends, you can actually go and view your logs. So you have a logs button here, which you can always use to see the same information, similarly to the way that you saw the information on lens. So this was about how we ran the Kafka experiment for a success case. And I mentioned that there is something called as a chaos result. Let me show that very quickly. This actually gets created. Okay, I'm on a different setup. Let me do this on my actual console. Okay, you can do it on Lens as well. So there's something called custom resources, Litmus Chaos.io, and chaos the result. Yeah, so here it is. So you can see there's the custom resource. It has information about what happened to your individual probes and what happened eventually to your experiment. It has the status of the experiment currently, and you will be able to use this information to generate some useful reports to see what has happened with your different chaos runs. So it has some metadata as well, what experiment it is running and what chaos engine it belonged to. All that information is available here. So this was about the chaos result, and this is how we went ahead and ran an experiment. So I just can take some questions here before I move on to the next part of the demo. I can do the failure run for this, but it's going to be the same. A couple of probes are going to fail, and the chaos result is going to show up as fail instead of pass. So that's about how you can run a chaos experiment using the portal. This is how you can define your hypothesis using probes and how you can visualize things using the portal. And you also saw the chaos result. Yeah, that's all I had to show as part of this demonstration. And I can actually go ahead and show the next chaos experiment, which is going to do chaos not on a Kubernetes pod, but instead on an EC2 instance, right, on Amazon Cloud. So Uma mentioned during his talk that you could provide details of your cloud, the credentials, and it's going to use the API provided by the cloud provider and go ahead and inject some chaos. We're getting started on this stream, non-Kubernetes chaos, but we do have a few useful experiments that you can already start. But before I actually go ahead and show that, I just wanted to take some questions, if there are any around what we just discussed. Yeah, so here
Yeah,
are the logs, like I mentioned.
yeah. I guess there's a few things kind of floating around my head. Like, what's involved in providing support for additional probes beyond like the Prometheus probe, the command probe. Like, if I wanted to support, uh, maybe taking a look at some logs on Loki or querying InfluxDB, or even reaching out to external systems to understand maybe like actual user feedback or requests. Like, are the probes complicated, or is there something I can throw together pretty quickly?
Yeah, so the probe documentation is available here. You can take a look at the different kind of probes. We use the Prometheus probe and the command probe in our current experiment. There are also a few others. There's a HTTP probe which you can use to get the availability of some downstream applications. You could provide the response code, and you could do get, post, different kind of HTTP commands, and verify if things are good here. There's something called as a KTS probe, which is essentially trying to get information about Kubernetes resources. So there are a lot of custom and native resources on your cluster whose status you might want to observe, especially in the age of operators. There are a lot of applications that are being managed by operators, and you will find a lot of information about the health of those applications in CRs pertaining to them. So if you want to get information about those, you can also use KTS probes. But you raised a great point, David. We can always extend these probes. The way they are being written is we're trying to make it a modular thing. So you can actually fit in more probes. You can have more probe sources or probe types. You can have probes that are specific to some service meshes. Say, for example, you can have something related to Thanos or Loki. Yeah, you can create probes like that, and there has been a lot of interest in creating new type of probes, as well as trying to extend this probe framework to do things like chained probes and conditional probes, running some probes only depending upon the result of others, and trying to use the output of one probe as input in another, which is what we're calling as chaining. All that is something we are working towards to improve this hypothesis validation framework. Definitely something to consider, and we'll be really happy to take more user feedback about this. An issue on GitHub would be great.
Yeah, I find that part of it really interesting. Because it's a cloud native project and people are running Kubernetes. There are a lot of people that are using Prometheus, and that makes a lot of sense and why that exists as one of the first set of probes. But with the rise of open telemetry and that agnostic layer to where we store metrics, a lot more people are now starting to look at maybe Datadog or Honeycomb, and being able to query those as part of that probe, I think would be really important. Um, okay,
Absolutely.
what if I want to get rather destructive using Litmus Chaos, like actually attacking the Kubernetes API server to see what happens to my cluster? I mean, is that ill-advised, or is that something that is potentially possible? And I'm curious about the way that things are reconciled if I do break the API server.
Yeah, we've had people try a few things like that. So what happens if it's something that's a transient error, like you said, destroying killing the API server pod for a few seconds or minutes before it actually comes back? I think it's something that's doable. You might see things sort of getting stalled for some time. You might not see outputs and logs and things like that, but they'll eventually get filled back once the Kubernetes control plane component is back up. So we've had people doing that kind of case, but if you want to do something larger scale, something more destructive for a longer period of time, something that is being discussed in Litmus circles via we will be able to, or we will enable doing chaos on Kubernetes control plane itself by staying outside the cluster. The Litmus experiment business logic allows you to do that, but today it runs as a pod. There are also plans of running it as via CLI, where you sort of effectively outside the cluster, you don't really run as pod, but you're still able to go kill things. You're using K8s API, and you also have other checks to see if your API is not responsive, how long you can wait for the experiment to continue to run, then check the status and things like that. So you could do it today, but only for transient errors. But if you want to do it for longer periods of time in a much more destructive way, killing Kubernetes itself, I think that's something that we will enable over time. Having said that, there are a lot of add-ons that people run in Kubernetes. Something that you could also see on the portal. There is a category of experiments called as Cube components, something that the Intuit folks have been driving in for some time, which is essentially some add-ons that they have in their Kubernetes clusters. So there's some Prometheus and some Ingress controllers and kubeproxy and few things, wavefront controller, few things like that. So you could actually you wouldn't call them as most important, of course, kubeproxies, but there are a lot of supportive tools when you run your Kubernetes workloads, when you're bringing up your staging or your production. It's not only going to contain Kubernetes and your business applications, but a host of other things from the CNCF ecosystem that form your overall framework. It could be observability, it could be compliance things, it could be databases, it could be so many things. So you could use Litmus not just for your core application, but you could use it for other infra components as well. And if that infra component happens to be the Kubernetes control plane itself, some of it is possible today and some of it is going to be enabled in the future.
Yeah, okay. I think that's a really interesting thing, like when there is a component that runs outside of Kubernetes, because I can imagine bringing in, maybe probes or even chaos experiments themselves to integrate or work with eBPF and really start to do some crazy stuff there would be a lot of, I don't want to say fun, but it does kind of sound like fun. So,
Yeah.
all right. I think that's the only questions I have right now. If you want to do the failure demo, and then we can do a quick
Yeah,
wrap up.
I think there's just one small thing about doing chaos on EC2 instances. I can probably just share that. It's probably not going to take too much time. It's very simple, very similar to what we did with the Kafka experiment. I'm just going to schedule a workflow and I create my own workflow. And I can upload my YAML that has the EC2 terminate stuff here. And you can see that this chaos engine is basically trying to kill an instance which has this ID. It can also kill instances randomly if you choose to. Has some details here. And this particular experiment also uses a cloud secret, which I already have on my cluster. So there are some secrets that I created here for holding information about my, and this is on next cluster, I think. All right, I think it's the same one. Yeah. So there is a secret which holds information about my AWS access. So I'm just going to go ahead and run this, and you know about the residency scores. Yeah, and it's going to run a new experiment. And the idea for that is one of these cluster instance IDs, this one to be precise, is actually going to be stopped for some time. And this node happens to be a worker node of a Kubernetes cluster, a KubeADM Kubernetes cluster on AWS. So in case you want to do something more disruptive at a workload level, you do have node-related experiments in Litmus, which are only using K8s API, like you have node drain. You basically create eviction taints and push out all the pods to effectively simulate a node shutdown, things like that. But if you want to go and do something hard resets like that at the provider level, you could still do that. And these are experiments that will help you to do that. So this experiment is going to be in progress. you can see that there are some easy to terminate experiment pods that have come up here, which are actually going to do this experiment. And in this experiment, the hypothesis is very simple. I'm just going to kill a node. I want to see a pod, an Nginx pod, is rescheduled successfully and it is coming back to running state. More like a vanilla, vanilla case of a chaos experiment. So let me go ahead and show you my EC2 instances. I think I need to do this. Yeah, you can see that it has been stopped and it's going to come back to running state. The hypothesis also includes a check on whether all the nodes in this cluster are back to running state. So we want to leave the cluster in a similar state as we started it. So it's going to check whether things are all online after it gets back. So that's essentially what this experiment does. And yeah, you can see that it was brought back. So that's very quickly how you could run experiments on AWS instances. You can also do EBS detach, do something similar on Google Cloud as well. So yeah, so that's about how you can run different chaos experiments using the portal. A lot of these workflows and all the information on how you can set up clusters and how you can run these experiments are all available here. You can share that on the chat or on the YouTube video comments. So please feel free to take a look at that. That's pretty much what I had, David, in terms of installation and then how you can run experiments.
Awesome. We covered an awful lot there. Really interesting stuff. I hope other people kind of enjoyed what they see and they go and give Litmus a play in their own infrastructure. All right. We've gone a little bit over, but I'll just give you both the opportunity. Is there anything you would like to finish on just now? Anything you'd like to say before we say goodbye to our audience and leave them at that?
Yeah, I think we can stick around for a few minutes and take any questions.
All right. If anyone has any questions, you've got 30 seconds. Drop them in the chat or forever hold your peace. The show notes will include all of the links that were covered by both Uma and Karthik. They will be available in the YouTube description. Yeah, I hope people enjoy playing with Litmus. All right. I don't think we're going to get any more questions. All right. I just want to say thank you both for joining me today. Really interesting project. Lots of really exciting stuff there for people to do and play with. The demos were great. It was good to see, that some of those experiments can resolve nicely, which I hope we all hope. But of course, when they go bad, at least we have the visibility, the monitoring, and observability, all those other tools that we really expect people to do. Do not go unleashing chaos into your clusters when you're not ready. Right? Very dangerous. All right. Thank you both again. I hope you have a great day, and I'll speak to you both soon.
You too. Cheers.
Bye.
Thank you. Cheers.